Okay, hi everyone. That's Tomasz Stanczak from Nethermind, but also working at Flashbots and TwinStake. And this topic today is actually somewhere on the meeting point of all of those projects that I've been working on. So I'll be talking about the future of MEV in Ethereum. So I want to show that MEV has actually a deep impact on how we think about the protocol security, about the Ethereum future, about how we build financial markets, and how we keep the user value where it should be, so staying with the user. We'll talk about MEV-Burn, about ePBS, about the road to SUAVE. Okay. So at least a few topics that are all related to the future of Ethereum, and you can see on the right, this is the updated roadmap from Vitalik. So Vitalik keeps sending that roadmap vision for Ethereum with a list of all the topics that are being started. It's probably like 100 of items there at the moment, with a few hundred core developers working, researching, developing solutions to all of these important aspects that are either paving the road for user adoption, increasing the protocol security, usability, making sure that there is much more decentralization and fairness in how Ethereum looks in the future. And many of those solutions are borrowing the ideas that are developed in other blockchains, improving on them, or simply replicating, or sometimes, or very often, defining of what will be delivered in other chains in the future. So showing really that innovation path that Ethereum has been actually participating in for many years now. So the topics that I'll cover today are only a subset of those that are relevant for Ethereum future. They touch things related to economics, to staking, to MEV. So the first one is MEV-Burn that is addressing the problem of overpaying the validators during the time of the spiked volatility. So we'll see how we can introduce the mechanism that is similar to something like EIP 1559 for gas prices for solving the problem of unequal payments of MEV. So unequal payments of the benefits from the arbitrage, on-chain arbitrage to the validators. We'll talk about ePBS, so enshrined PBS, proposer-builder separation, and you'll see that those two topics are related. We'll talk about restaking, which is close to the staking world, the post-Chapella Ethereum with the staking rewards and withdrawals, and now the road towards potentially a next interesting thing and hype of reusing your deposits, the validators, to support more protocols and more functionalities. The shared sequencers topic, something that is very important for the future of bridging, of bringing the rewards to validators, of connecting rollups together, bringing interoperability. Geographic decentralization, which is a topic that's very important for us, maybe from the perspective of delivering Ethereum as a global public good. How not to forget about building protocol that is decentralizing power around the world, not only with the global financial hubs, but also to the global south, connecting, bridging Asia with Europe, Asia with US, and so on. We'll talk about MEV-Share for order flow sharing, the account abstraction topic, cross-domain MEV, and finally, I'll try to show how SUAVE, the product, the overarching product from Flashbots, is connecting all of those things together. How we think that Ethereum with SUAVE builds the future for geographically decentralized, privacy-enabled, decentralized market for value extraction, and value extraction not by those in power, but by users back to the place where that value is created in the first place. Okay. And if you'll be listening to me, but you would prefer to actually read while you do that, so this is the link that you can simply screenshot and start checking now, and also refer to it later if you see the recordings. So I used mostly those sources. I try to focus on the things that are the newest, the freshest, so you can think of it as a research from the last month or so, and the main protocols that are being developed now. So now, after using this lots of fancy words, I come back to the glossary, so maybe to let everyone join this short journey. So what is MEV? It's a minor extractable value, so think about it as a value that is available to those participants of the protocol that have privileged position on blockchain. So in the Ethereum space and in many other blockchains, you can think that this privileged position is mostly with the validator or miner or those who are actually constructing the blocks and sending that block to the network, those who decide which transactions go in, which transactions pay transaction fees, and what financial operations are happening on blockchain. The privileged position because they are perfectly placed in the timing of like decision placing and available to extract that value of the misaligned prices on the markets, of maybe pending liquidations, and so on and so on. So this MEV topic and the fact that that value always exists and there is always some kind of like a sequential series of events on blockchain means that sometimes always there's someone in the right place at the right time, and we need to think about how to smoothen that privileged position, how to redistribute it back to the users through the protocol solutions. The bundles, I may use it a few times during the talk. So bundles are a group of transactions that you're sending together, and they're very often not defined by the protocol, but it's just like a package that is used very often by extensions through the communication layer of the protocols or protocol extensions that build on top of a mempool, or creating private mempools on top of the public mempool, allowing to send a few transactions together with some additional metadata telling how to process those transactions together. And then an important distinction between all the aspects of who participates in block building and block propagation, we're splitting the traditional role of a miner or the role of a validator nowadays into a sequencer, builder, proposer, validator. Sometimes it's the same node, single operator, but sometimes, and especially with the introduction of the protocol extensions that Flashbots builds together with researchers from Ethereum Foundation and other teams that deliver MEV solutions, very often we actually think about how to separate those roles. So then we say that sequencer is the one that collects and orders transactions. The builder is the one that builds a block out of those transactions, maybe by selecting a subset, or maybe by adding additional information, metadata to the block. The proposer is the one that actually decides which of the different blocks to broadcast, to publish to the network, so selects the block that is most beneficial to them or to the network in general. And the validator as a role, I define it as those who participate in a consensus security. And as I say, those roles can be split in the various ways. But the most important split that we've introduced in the last months, practically since the merge in Ethereum, since September last year, is the proposer-builder separation. So those who build blocks, so practically combined sequencer and builder, are separated from those who push that block to the network and validate network. And this is because the validator or proposer has that security responsibility, and you want to make it as light operation as possible, so those who are responsible for security can focus on it entirely and don't have to worry about that very complex, financially heavy role of the block builder. Those who scan for the opportunities on the blockchain to select best transactions and build the best blocks to extract the most value. All right, so first I'll talk about the MEV-Burn and MEV-Smoothing. So as I mentioned, the MEV-Smoothing and burn are all about removing the spikes of volatility and the unequal distribution of the spikes of volatility. So you think about the large events in the market, like a collapse of a centralized exchange, like October, November last year, like things like Luna in May, or some announcement about regulatory actions, litigations, or even unrelated to the blockchain markets, the global markets collapses, or some good market situations. So all of those increase volatility. The prices of assets start to move a lot, and suddenly much more transactions are being created by financial markets participants to take advantage of those situations. They try to move assets very quickly, some liquidations happen, the prices are misaligned between different decentralized exchanges, some new opportunities appear, new products that are maybe suddenly stress tested in that situation are starting to fail. In those situations, a handful of validators that are randomly selected to produce blocks at that very moment are having a great advantage to actually take that value for themselves. Like the searchers, the arbitrageurs on the market pay huge transaction fees to those few validators. They're on Ethereum at least, they're randomly selected for that time, and they may maybe take home like something like 100 ETH for every block that they produce. The problem is that actually from the security perspective, it's undesired. Even from the perspective of many of the operators, whether solo operators or large node operators, it's also undesired. It creates some kind of unpredictability of the rewards and possibility of some so-called reorg attacks. Those who were not selected for those particularly valuable opportunities, they may go, you can imagine in the future, maybe some major roll-up collapse will lead to something like 100,000 of ETH rewards for a single block. So in those cases, you may think someone can decide that it's worth to put the Ethereum at risk just to reorg the order of blocks to get that reward for themselves. So MEV-Burn is all about introducing a solution that smooths that problem. And it's the discussion is currently happening on the ETH Research Forum. And what it will lead to, very likely within a year or two, because this is the timeline that we're talking here about, maybe like between 1 and 3 years from now, we'll introduce a solution that will start redistributing that MEV, either through the burn or through smoothing of the redistribution among the validators. So why MEV-Burn? It's a solution similar to EIP-1559. The same way as an EIP-1559 forces the base fee to be burned, and burning of Ethereum, you can think of it as a redistribution of value to all the holders of Ether. Because everyone who holds ETH is suddenly having a share of a smaller pie, so theoretically the dollar value of that ETH should be higher, right? So that's why we're redistributing to all the holders if we burn. And MEV-Burn says that if there is 10,000 ETH opportunity, then instead of having multiple builders to try to compete for that and bid to the block proposer, to validator, to make that payment of like split maybe 7,000, 3,000, we force those builders to actually bid for burning as much amount as possible. So they may end up burning something like 9,000 ETH and taking 1,000 between validator and block builder, and that 9,000 burn, similarly as we've seen in the ultrasound dashboard, is leading to the global decrease of the total cap or decrease of the total available ETH. All right. So MEV-Burn is related also to proposer-builder separation, because it's the current proposal of MEV-Burn, of how it will be architected, are based on the communication between builders and the proposers through the peer-to-peer network. So there'll be a series of messages together with the attestations from the Ethereum block beacon chain that will observe what happens and split the block construction role into like multiple phases. The phases when the bids with the highest MEV-Burn are proposed, the best block is selected, and a tester saying this is what we've observed as the highest promised MEV-Burn level. This is what we've observed as the block selected by the proposer, and so on, so on. So multiple stages leading to the block selection. But for that to happen, we need to have a modification from PBS today, which uses the centralized relay in between the builder and proposer, into PBS endgame, some work for the 1 or 2 years, where we have just builder and proposer communicating over P2P network, and the attesters just monitoring what kind of messages they notice on the on the network. So this is, even nowadays, when we have the validators on Ethereum proposing new blocks and participating in security, you have those attestation committees that are observing what really happens. And they agree on the state of the network. They say, this is the best block that we've seen, in a way. This is the block that we commit to. This is the history that we all agree on. And we can start kind of overloading that responsibility of the attestation committees to provide a bit more and more functionality. What comes else? So this is maybe slightly on the side from that, or maybe different topic. What's coming to Ethereum is also restaking. And I think that there's a big prediction that there'll be a lot of protocols that will start taking advantage of restaking. And it might be also a lot of misleading advertising of the benefits of restaking. And I think the understanding of the risks of restaking, understanding of the opportunities of restaking will be an important role. And one of the things that at Nethermind we start to work on in collaboration with EigenLayer is to understand, to provide some common framework to the users of how to best analyze the risks of restaking. And what is restaking? Restaking is using your deposit from Ethereum and using it as a potentially deposit for another protocol that is slashable under other conditions. So instead of using deposit directly for validator in Ethereum, we deposit 32 ETH through a smart contract that has additional logic that says that I have additional responsibility to either validate or maybe provide the data as Oracle or maybe settle some additional financial protocol transactions or maybe liquidate in time and so on and so on. I have additional responsibility, so also I potentially have additional punishment. If there is additional punishment, it means that I put my deposit from Ethereum, which is designed to secure the Ethereum network, 32 ETH that is actually used in all the calculations of the network security, and I put it at risk of additional slashing, so suddenly we have the additional risk of the network security, just because of some overhyped, well-marketed project that is inviting all the validators to restake with it, may fail, may cause the massive slashing, which may lead to the decreased security of the entire network. And I think that understanding of those risks, but also opportunities, because it leads to additional rewards on top of your stake, is what will be very, very important aspect of building on restaking. And I hope you all take it into account when you'll be planning restaking in a few months when it happens. The next topic, so shared sequencers. So this should be, again, coming to Ethereum, I guess, maybe in a year, maybe a bit faster in the first examples. Maybe it's already there in some very early forms. And this is very important for the rollups and for the world also of a cross-chain MEV, as the shared sequencers are promising the role of building blocks for multiple chains at the same time. And when we think about multiple chains, usually they'll exist within the same domain, like within the same family of chains. You can think of it as a maybe Optimism stack with superchain, or some solutions across, like for Starknet, like all the layer 3 on Starknet and layer 2, or Ethereum ecosystem as Ethereum and its rollups together, or maybe something, well, I guess in Cosmos we're talking more about the Cosmos-specific solutions. But here about Ethereum, the shared sequencers will bring the bridging capacity, the potential cross-domain MEV extraction, and potential significant decrease of the cost of security of building a new rollup. So shared sequencers, and I invite everyone to read a very long but very comprehensive article from Jean Charbonneau, which I link here, to understand really this scope of what are shared sequencers, what is decentralization, spectrum of all the sequencers that we can build, and how many functionalities we can do to the overloading the sequencer, or like proposer world. Geographic decentralization. So there is a bit of like a geographic decentralization manifesto from Flashbots that says that as now we are defining the protocols for MEV, for rollups, for new layer ones, there is very often an incentive to build for latency, to market the products, market the L1s or market L2s that they have the lowest latencies, that are fastest in processing transactions. And there is a risk that through that we see the geographical centralization, that to catch up with the network, you will need to co-locate the validators in a single region, that you'll have to be close to the block builders to deliver your transactions as fast as possible, and so on and so on. It's this like famous world of the traditional finance where you're buying the space in the same rack in the data center to be as close as possible to the decentralized exchange operator. So geographic decentralization means that for all of us in the, like among Ethereum research, Flashbots, Nethermind, and so on, whoever works on the protocol, it's important to have it always at the back of our minds that the design of protocol has to take into account that when we design for latency, we design for centralization. So we should have the protocols that ideally do not deliver more value to those who have higher latency in delivering messages to some reasonable level, I think. So there has to be some compromise. Obviously, you cannot wait hours, but if you start thinking of maybe milliseconds, that it might be that the protocol should have some modifications to simply batch together, collapse transactions over time. Well, this is also an opportunity to think of how to keep bridging the various regions when building. So breaking the barriers of either language, understanding, communication, meeting together, and introducing the infrastructure from different regions and building cooperation. So I think whenever we see builders from the West coming here, or vice versa, there's an opportunity to start building protocols together and build them together from the beginning with the validators in the regions from two ends of the world, and making sure that even within those latency situations, high latency situations, the protocols are operating great. So I feel that on the Nethermind side, it's always invitation for cooperation between Nethermind that tries to be global, but definitely has a bit of like European roots, and that's when much of the infrastructure for Nethermind exists. Cooperate and collaborate and invite to collaborate for anyone here in the Asian region to help bring those infrastructure operators to the Ethereum ecosystem. One more thing that is coming, or it's almost being deployed now on mainnet in the 1.0 production version, is MEV-Share. It comes from Flashbots, and it talks about the order flow sharing. So how to, and by order flow we mean here the list of orders or transactions from users that flow usually through the wallets, through the front-end transactions. So it can be maybe the list of Uniswap orders, or the orders from a wallet like MetaMask, or the list of orders through 1inch, and so on and so on. So that order flow in traditional finance market very often is a part of transactions like OTC transactions or order flow selling. So we go to some broker platform and we don't pay fees, but our order flow is being sold to the market makers who take advantage of the knowledge of the excuse me, to the knowledge of in advance of the market movements, of the direction of trades, and they trade against that flow or background on top of that flow. And we want to introduce solutions having potential in blockchain for the privacy, for the control, for both privacy and transparency. We're introducing solutions that are protecting users on the side of ensuring that we do not give away the details of a transaction too much. We just share some aspects of it, but not everything. So the user transaction cannot be front-run, cannot be taken advantage of, but we share enough information that the transaction can be background, which means that whatever misalignment in the prices on the centralized exchanges it can introduce can be detected background, and then the value can be shared with user back. So I make a large trade, let's say, as a user, can be large company, right? Can be a user as well. So you think of a user as maybe a single person using the MetaMask, but we're thinking here of a user as maybe a large company operator that makes a trade for $10 million to change from one currency to another. And if they introduce a trade like this, then they can move the prices significantly, and ideally some of that value misalignment, if detected by arbitrager, can be paid back to the user. So MEV-Share comes from Flashbots, is at the moment in the beta stage on mainnet, and you can start connecting and analyzing how the matchmaking algorithm works, how we provide the privacy solution for the users to not show all the data of the transaction. Okay, and the account abstraction is one more topic that will have MEV, because when you think about account abstraction, it's like splitting the transaction into more granular level. So block is constructed of transactions, and the account abstraction ERC-4337 on Ethereum, we split further transaction into user operations. So user operations are some small actions that are signed by user, but signed not using the typical transaction signing methods from Ethereum, but any other abstracted way. So it can be signed with a password, signed with some custodial key by someone else, signed with some electronic ID, and so on and so on. So the same way as we can have MEV available for the block builders by reordering transactions, maybe even injecting transactions, and so on block level, the same way we can have MEV in the world of reordering and selecting the user operations to the transaction. So instead of block builders, we are talking here about bundlers, those who bundle transactions together, bundle user operations together to create a transaction. So now account abstraction gets a lot of attention. There are lots of builders, and it's good to start thinking that there will be a world of MEV in the account abstraction as well. The last one thing before SUAVE, I was actually asked to speak a bit longer, so I'm having, I think, 3 minutes more. So the cross-domain MEV concept, as I mentioned, with the shared sequencers and with the rollups and in the world of multiple layer 1 chains, we talk about extraction of value that is only possible if you have access to multiple chains at once. So in particular, you can imagine solutions like Ethereum Polygon, or Ethereum Binance Smart Chain, or Ethereum Optimism, Ethereum Starknet, and so on. So what if I can only liquidate a position on Ethereum if I move the assets first from Starknet back to Ethereum? What if I can do that in a transactional way? So if I'm using shared sequencer, then maybe I'm guaranteed to do that. If I'm not using shared sequencer, can I introduce mechanisms that allow me to make a promise that I will be able to do that in a transactional way? So there is a solution, or like multiple solutions that we're researching at Flashbots now that will allow us maybe to improve the mechanism of providing those promises and providing this communication layer between the block builders on multiple domains and the domains themselves. So by domains, I mean maybe decentralized exchanges, centralized exchanges, layer 1s, layer 2s, and so on. And finally, we say that for Flashbots, there is a SUAVE as a unifying solution, single unifying auction for value expression. So allowing users to express what has value for them, what is their intent, what they want to achieve, where they want to trade, and allowing them to participate in a single auction that unifies all the domains, while at the same time providing users with privacy, providing users with a full decentralized permissionless access to the financial market that is fairly redistributing that value back to where it's created, so back to the users. Which when you think of something that we've, at the beginning, been considering an important aspect of blockchains was disintermediation. Not having intermediaries that were charging the fees for execution of the most simple operations, as we see it in traditional finance. So in SUAVE, we have an idea that by introducing systems that are permissionless, redistributing value back, and operating with privacy, you no longer need intermediaries. You simply allow users to connect to the system that works, that provides the functionality of participation in financial markets, and distributes value exactly in the fair way. So you no longer have the intermediaries' fees. And this is a long, long way from multiple steps, components, progressive decentralization, removal of centralization bridges that let us jump from one stage to another forward. And some of them are MEV-Share, some of them are cross-domain solutions, some of them are solutions like enshrined PBS. Everything that we talked about is part of this. Thank you so much for listening. Contact details. Thank you.